On July 9, 2026, hundreds of thousands gathered at the illuminated shrine of Imam Reza to view the remains of Ali Khamenei. The pristine condition of the body, undecayed after months in the earth, sparked immediate whispers of a divine miracle. The timeline of this event begins 4 months earlier, on February 28th, when a joint U.S.-Israeli airstrike killed the Iranian supreme leader. This creates a highly specific temporal gap. We are looking at a 131-day post-mortem interval between the time of death and the public funeral processions. In forensic taphonomy, the baseline expectations for a body left in the earth for over 4 months are rigid. You should expect to see advanced putrefaction, if not near complete skeletonization. When a body is crushed in a damp environment, that process accelerates. Physical trauma exposes internal tissue to aggressive bacteria, and moisture speeds up cellular breakdown. Yet the remains observed in July bypassed this biological law entirely. The tissue remained preserved on a macro level. To understand why, we have to examine the specific geographical and architectural parameters of the death site, a collapsed leadership compound in central Tehran. This 131-day preservation is not a supernatural anomaly. It is a mathematically rare biochemical event, forced entirely by extreme architectural collapse. The compound housed the Habib Ebrahimi bunker, constructed by the Islamic Revolutionary Guard Corps between 30 and 35 meters below ground. When the strategic munitions detonated, an immense footprint of concrete, steel, and urban earth collapsed inward on the bunker. This massive cave-in generated an immediate physical effect on the microenvironment below. It created an instantaneous, high-pressure, hermetic seal. A standard grave burial remains highly porous. The loose soil allows for continuous water drainage and gas exchange with the surface. That gas exchange fuels the biological engine of normal decay, aerobic putrefaction, driven by standard necrophagous bacteria. For aerobic putrefaction to occur, those bacteria require a continuous, uninterrupted supply of oxygen. At the moment of impact, the environment transitioned from a livable space to a completely sealed taphonomic void, instantly cutting off all airflow from the surface. The sheer violence of the architectural destruction forged a perfect stasis chamber. It physically removed the prerequisites for normal biological decay. Within this newly formed 35-meter-deep microenvironment, the first phase of preservation began, Anoxia, or total oxygen depletion. Any residual oxygen trapped in the rubble was instantly contested by 2 forces: early-stage cellular autolysis from the body itself and the surrounding soil microbes. This intense biological competition rapidly consumed all available oxygen molecules. Within hours, the oxygen levels in the sealed pocket dropped to absolute zero. If we look at this volumetric model of the space, we can see this dense cloud of O2 molecules rapidly diminishing to zero along a very short timeline. The direct consequence of zero oxygen is the complete suffocation and shutdown of standard aerobic putrefactive bacteria. Without these specific bacteria actively feeding, the primary engine of human tissue rotting is completely neutralized. There are secondary organisms that can survive this vacuum. Anaerobic bacteria, such as Clostridium perfringens, thrive in the dampness of the deep earth. However, their decay pathways operate entirely differently than their aerobic counterparts. The bunker's extreme depth met the first necessary condition for 131-day preservation. By forcibly removing oxygen, the microenvironment shifted the body's chemistry into anaerobic stasis. This damp anaerobic environment triggers the next phase of the biochemical cascade, hydrolysis of adipose tissue. Human body fats are primarily composed of triglycerides. In the presence of water and anaerobic bacteria, these fats become highly vulnerable to breaking down. This chemical pathway model shows exactly how a complex triglyceride molecule splits into simpler, saturated fatty acids, primarily palmitic and stearic acid chains. But for these loose fatty acids to solidify, a mineral catalyst is strictly required. Specifically, the reaction demands high concentrations of calcium and magnesium. That catalyst was provided by millions of microscopic pulverized concrete dust particles raining down from the destroyed architecture. As we see here, those incoming calcium and magnesium ions from the concrete dust lock directly into the stearic acid chains, forming a rigid geometric lattice structure. The resulting chemical compound is called Adipocere, commonly referred to in forensic taphonomy as grave wax. Adipocere forms a hardened, soap-like shell that entirely replaces the outer soft tissue. This waxy encapsulation renders the remaining internal organic tissue physically impervious to further bacterial degradation. The explosive destruction of the bunker inadvertently supplied the exact chemical ingredients required to saponify the remains, casting them in a permanent waxy shell. The final, most extreme taphonomic variable comes directly from the specific payload of the bunker-busting munitions used in the February 28th strike. Specialized deep penetration ordnance utilizes trace heavy metals such as depleted uranium or tungsten to maximize mass and kinetic density. Upon detonation, these heavy metals atomized, deeply saturating the dust cloud trapped within the sealed 35-meter void. These jagged, microscopic heavy metal fragments violently pierce and embed themselves directly into the lipid walls of organic cells. These heavy metals are profoundly toxic to any putrefactive bacteria trying to feed on the remains. This triggers a process known as protein denaturation. The metals chemically warp, unfold, and destroy bacterial enzymes on contact. Looking at this spatial model, the heavy metal particulates embedded in the tissue radiate toxic zones. They instantly denature and dissolve any approaching bacterial organisms. This heavy metal infiltration effectively sterilized the microenvironment. It halted any residual decay that had somehow survived both the Anoxia and the Adipocere encapsulation. The total preservation required a tripartite chemical anomaly: 1. Anoxic sealing, 2. Concrete saponification, and 3. Heavy metal sterilization. During the July funeral processions, the public perceived this lack of decay as a supernatural intervention. The pristine condition of the subject after 131 days is a predictable, catastrophic biochemical equation, solved precisely by the architecture of the bunker and the munitions that destroyed it.